reminding me. And what we were doing, Aditi, in the last class?
We're doing questions, questions, and we talked about Hess's law at the very end.
Oh, and we are going to do the questions on the Hess's law, right?
Yeah.
And I said that I'm going to give you introduction about the Hess's law again because we started some question, but I didn't explain you the concept very well. So I'm sharing the whiteboard to make you understand Hess's law in a better manner. Okay, before we start the Hess's law, we need to understand one important property of these thermodynamic quantities, that is, they are state functions. State functions. So somebody can talk about this particular word when you are talking about Hess's law. Now, what is state function? State function is a quantity which depends only on initial and final. Depends only on initial and final. States. What is the initial state and what is the final state? Like, for example, if I give you a cup of water, and this water here in this cup, the water is 20 degrees Celsius, right? If I ask you, okay, Kyra, you go and raise the temperature of water to 100 degrees Celsius, boil it. And then I asked Aditi also to raise the temperature to 100 degrees Celsius. But Kyra is in some jungle. She doesn't have electricity and all these things. She has a matchstick with her. That's it. So Kyra, you are in a jungle. Aditi has only electricity available, heaters available with her. 100 degrees Celsius. Now, I have given you the same cup of water, same amount and the same cup to Avni. And Avni is in a desert. Okay. Desert will not help. Avni is in a desert where she has the accessibility of the petrol, gasoline. Okay. Now tell me, Kyra, can you raise the temperature to 100 degrees Celsius? How?
Yeah. Matchstick.
So you will burn the woods and you will heat this cup of water and you will raise the temperature by using fire from the woods, from the dry woods of the jungle, right? And Avni, you will use a heater, correct, Avni? Sorry, Aditi. Aditi, you will use a heater
Yeah.
and you can also get 100 degree. Kyra is also getting 100 degree. And Avni, what are you going to do?
Maybe I'll use the petrol and start a fire
Yeah.
with rocks.
Yes. Oh, yeah, that is also available option. So you are using three methods. But when you come back, am I interested in which method you have used? I'm just interested that is the temperature 100 now? And then you will say, yes, we all are with 100 degrees Celsius temperature. So what is temperature? Temperature is a state function. It is a state function. It depends only on initial temperature and final temperature. It doesn't matter how you have reached it. Paths are different. In one case, I'm using fire. In one case, I'm using heater, electricity. In another case, she is using stone and then petrol, burning of the petrol. Is it okay? So here the delta T, the difference in temperature from 20 to 100, does not depend on path. It depends only because delta T is 100 minus 20 for all of you. What is delta T for all of you? 80 degrees Celsius. And it doesn't matter which path you have followed. So it means state function, they depends only on initial and final state, and they do not depend on the path. Can I write like this also? Do not depend on path. What path you have followed to do it. I give you one more example here. Let's say there is a mountain and I'm asking you to go on the top of the mountain here, and you have three different ways of going on the top of the mountain. One, you start climbing like this. Second, you start climbing like that, like this, in a spiral motion using a car or something. Third, you take help of a chopper and get landed over here. Do you think the amount of work done by you three is the same or different? One, let's say Aditi is walking up like this. Kyra is using a car and going in a spiral motion like this. Avni decided to take the help of a chopper and getting dropped on the top of the hill. So is the amount of work done by all of you same or different? Who
Think
did the, who did the maximum work? Who is more tired?
Aditi.
Aditi. So the amount of work done is not same. Like Avni didn't do any work. Her work done is zero because she just lifted herself like this. If you do the physics, then work is force multiplied by displacement, and then there is an angle here 90 degree. There is cos theta also. What is cos 90 degree? You have done this cos theta sin theta in mathematics. What is cos 90 degree? Isn't it zero? Because I'm not using this equation much, so I don't remember the value. Which one is zero? 10. Is which one is zero? Sine 90 degree.
I thought it was tan, but I don't know.
No, 10 I think is infinite, something like that. 0/1. Okay, whatever. We have not done, so we can ignore it. So something like this in the equation of physics. So Aditi, she did the maximum work. Avni did the minimum work. And Kyra also did the work when she is traveling with the car. She's pressing the accelerator and all these things. She's working. By the time she reaches here, she's also tired. So the maximum work done by is Aditi. So is the work, which is small w, which you already know the symbol, is the work a state function? Is not a state function. Work is not a state function, right? Work is not a state function. You're understanding this? Why? Because it depends on the path. What about the total change in potential energy from here to here? You were here earlier. Is the potential energy, the total change in the energy, is it a state function? Yes. You use different paths, but the delta E is same, so it is a state function. So delta E is state function, delta H is state function, delta S is state function, delta G is state function, delta V state function, delta T state function, delta P state function. Means they depend on initial and final. Right? Avni, You're not making notes?
I am,
Okay, okay.
but like I'm just taking screenshots and then I'll
Oh,
like
okay.
do it later.
Okay, okay, no problem. So the state functions are always with capital symbols. You see, in all the cases, I'm using capital symbols. But for the work, I didn't use capital. I used the smaller one. So that's a kind of easy to see. Oh, some small symbol means I'm not dealing with a state function. Do you remember the symbol of heat, which we were using earlier? Q. Is it a state function? No,
Oh,
it's not a state function. If you see, when Aditi is climbing, the heat generated by Aditi will be more as compared to Kyra, as compared to Avni. Avni, no heat generated. She just not doing anything. When you do the work, heat is generated. Work and heat are related to each other. So Q, small q is not a state function. So I think the word state function is clear. It's very important because we are going to use the state function concept as Hess's law, which means you can use any path to calculate the delta H of the reaction. The same is valid with all of them. All the equations for the state function is always final minus initial. So I'm going to show you something here. You can write down because we'll be using it a lot in our questions. Like if there is a reaction, A plus B giving you C plus D, this is the reaction. Now I can put some coefficients here and AA, BB, CC, DD. Now this particular reaction, whether I have done it as a single step or in multiple steps, it doesn't matter. Delta H of the reaction will be the summation means adding the enthalpies of the product that will be given to you minus summation of enthalpies of the reactant. So you'll be doing some questions based on this equation. Now enthalpies of the product will be given to you. Same with delta G. Delta G of the reaction is also calculated by using the same equation. Delta G of the products minus delta G of the reactant because they are state functions. They are totally dependent on the difference of the initial and final. This is final, this is initial, final, initial. Similarly, delta S of the reaction. Do you remember what was delta S? S. What is this symbol S? Yes, we did it earlier. What is S? Kyra? Avni? Yes, Aditi.
entropy,
Very good. Entropy. What is entropy?
the measure of the disorderness.
Yes. What is delta G? Yes, Aditi.
Spontaneity, like, and it gives free energy.
Gives free energy. And what does it's going to tell you?
How spontaneous it is.
Very good. Excellent. Spontaneity of the reaction. I spent completely 1 hour on this, whether the reaction is spontaneous or non-spontaneous. Entropy is going to tell you the degree of freedom. I gave you plenty of examples. Degree of freedom. Randomness, measure of randomness. Kyra, do you remember that? Do you have the same notebook, Kyra?
I put it like inside there. I'm having another notebook currently because my pages of my other notebook ran out. So
You must have it next to you till the time you are flipping the pages. Like she flipped the pages, few of them, but she was aware where to see. Okay, so please make the notes, Avni.
Yeah.
This is not good. You didn't answer it. Okay. This is the degree of freedom. So delta S of the reaction is also state function, which is delta S summation of the products minus summation of the reactant. Is it okay? So state function is clear to us. So I can use this equation on delta H, delta G, delta S, and I can use Hess's law also on them. Hess's law. First, these equations. Second, Hess's law. Because these two properties are governed by the state function characters of these thermodynamic quantities. So, ready to understand Hess's law as a state function? I'm going to clear it. Let's say there is a reaction A giving you the product, but the delta H of the reaction is this delta H RXM. But let's say you carried out the reaction in multiple steps. You converted A to B, then B to C, then C to D, and then D to P, right? Multiple steps. So I'm carrying out the reaction as A to B. I'm carrying out then B to C, C to D, and then D to P. I have delta H of every step. Delta H1, delta H2, delta H3, delta H4. Can you add these reactions? Add all of them. You're getting A to B. So what is delta H of this reaction? It's the sum of delta H1. Yes, Avni?
Oh, yeah. Just add all of the delta H's.
Yeah. But let's say I decided to carry out this reaction by another method. And this time A is converted into E, then E is converted into F, then F is converted into P. So now I'm doing it in two steps, A to E, E to F, and F to P. 3 steps. This is, let's say, delta H5, delta H6, delta H7. Now, Avani, what is the overall reaction?
Oh, it's A to P because the E's and F's cancel, and then the delta H is delta H5 plus delta H6 plus delta H7.
Now, Kyra, you are going to answer this question. She's saying delta H of the reaction is the sum of these. Delta H of the reaction A to P is this. Let's say it is X kilojoules per mole. So when I'm carrying out through this green part, green path, we can say path. Path is this. Then delta H of reaction here can be calculated by adding. So what's the value of this delta H of reaction? Isn't it same?
X.
Because, yeah, it's the same reaction. You'll get the same answer. And what is here, Kyra?
X.
So can I say whether I followed the green path or the red path, delta H of the reaction is delta H1 plus delta H2 plus delta H3 plus delta H4 and is also equal to delta H5 plus delta H6 plus delta H7 because delta H is a state function. It does not depend on the path which you have followed. You will get the same answer whether you follow the green one or the red one. So we are good with this? Ready for the question? Children, this is Hess's law, and this is how we have to understand the Hess's law, and then we can do the questions, the one which we started in the last class. Yes, please.
Is it like a flow definition? Because I feel like definitions help me a bit more.
Okay, that's really good question. So what is Hess's law? Hess's law states that the change in enthalpy of a reaction, change in enthalpy of a reaction, delta H of the reaction, does not depend on the path of the reaction and can be calculated by adding or subtracting. By adding, you can say adding, because finally we were adding only after doing the changes. By adding multiple steps. Enthalpies. I can give you more bookish language. This is something which I'm making you understand that it doesn't matter how many steps are there. So you can use any step. But if you want to see very bookish language, which is I feel is good, somehow I'm unable to recall now. So I'm just sharing a PowerPoint. Yes, Kyra.
Sorry,
Can I,
forgot to lower my hand.
yeah, can I move out of this whiteboard? I want to show you the real definition.
Yeah.
Can see it somewhere? Ah, here.
Yeah, that's it.
I also gave you something like this. Enthalpy
Yeah.
is a state function. It doesn't matter how you get there, right? And
Mhm.
this equation also I gave you, right? This one. But I said that I was teaching you in the combined manner. I said you can use this equation for delta H, delta S, and delta G. For all three. Even this Hess's law. For all three. These things will come in chapter, I think, 18 or 19 somewhere. Yes, Agni?
Can you send the notes?
Presentation.
PDF? Yeah.
Notes, right?
Yeah.
Okay.
Thank you.
I'm a bad teacher, really bad. I have everything, but somehow I'm every time forgetting that I have to do something for you people. I have to upload the notes and okay. Most of the time I'm busy with teaching and I'm shifting. Okay, no problem. I'll send you. I'll send you definitely. There's no need of reminding me. It's my duty. I'll send you. I have to understand these things. Okay, ready for the questions now? Opening the
Yeah,
book. I think I opened the PDF. No?
I still see
So
the slideshow.
I'm getting the questions. So we started the question already. Only the concept we have understood today, but in the last class, because time was less, so I started doing questions based on Hess's law. These questions I'll do after explaining you 2 more concepts, then we can do these questions. We did this 72, right?
Yeah, I think that's the one
Yeah.
we did last class. Yeah.
And we did 73? No?
I think we only did one question and then we undid.
Okay, fine. So let's do 73. And I gave you all the tricks how to check that there is a desired equation and how to get the desired equation. So I was telling you all the tricks. So write down the tricks that you are going to check unique reaction for unique reactant and products. Means don't pick up any reactant and product which is the part of multiple reaction. So focus on unique reactant and unique reactions, unique product and unique reactions. Okay, like here, what particular thing is present in multiple reactions? Can I say O3,
Yeah.
O2? So do not worry
Oh,
about
yeah.
them. Okay, just start working. How to get NO? This is equation 1, 2, 3. How to get NO? Which equation is giving you NO?
3.
The third one.
Third one,
third
take it
one.
as such. Yeah. And then which equation can give you O?
The second one.
The second one, but
Yeah, okay. I think equation 1 I'm not using anywhere. So I'm just writing it like this, NO2. NO2 is taken care, right? So equation 3, delta H3 I have taken as such. Equation 2. Equation 2, how should I take equation 2? Focus on this. What should I do with equation 2? Reverse and divide by 2. So
yeah.
it becomes
Yeah.
O2, half O2. So can I say minus delta H2 over 2? Now I'm left with equation 1. Is this O2? Yeah. I have to take care of this O2 because O2 is not the part of the reaction. So how should I take equation 1? How should I take equation 1? Is this correct? Is there anywhere else? Oh, O2 is the product. Yeah, here also O2 is there. So don't worry about O2. Don't think about O2. O2 is in 2 equations. Just start thinking about O3. You have O3 here, right? And you want to get rid of this O3. So how should you take this equation so that you can get rid of O3? You reverse the equation and divide by 2. Then it becomes 3 over 2 O2 giving you O3. Delta H1 will be minus over 2. Add all the reactions. These are the changes which I needed. And accordingly, I changed my delta H values. Now add all the reactions. When you add all the reactions, just check everything is cancelled out, what is not needed. O3, O3 cancelled. And half O2 plus O2 is how much? 3 by 2 O2.
3/2. Oh, and then that can cancel.
I rejected O2. I said, okay, don't worry about O2 because it's here also and here also. So that's the reason it's better that the equation 3 has O3 here. So you better start checking O3, which is the part of this equation. Do the changes so that O3 cancelled out. Rest will be taken care. And I'm getting the final equation. What's the answer? Right? And you plug in the values and get the answer. Kyra, any questions? Focus on the trick which I'm giving you, because that is more which is troubling. That is one which is difficult to understand also. So if you ask question, I can make it more clear. Yes, Apni.
So basically, are you just taking out the things that are like getting repeated and making a new equation, or?
This is my desired equation. And I'm just, okay, let me ask question. Somebody also raised their hand. Aditi, it was you?
Yeah, that was my question.
Yeah, so that's why I'm collecting the questions now. So that's really good that you are asking question. Look at this NO. And it is the part of only one equation, that is this. So decide that you have to take equation 3 as such. NO2 is also the part of this equation, right? Then look at O. O is the part of the equation 2. So getting up to these two is very easy. We decided easily, right? But after that, O3 and O2, they are not the part of my final equation. But now I will see after using these two equations. Check these two equations. What is the aim? Aim is to get rid of this O3 and O2. That is the aim. Now I said ignore O2 because it is the part of equation 1 as well as 2. So don't focus on it because that will confuse you. You have to do more. You can do it by that method, but it's time consuming. So where you are going to focus on O3, which will be easy because what I'm going to do, I will reverse this equation. Am I reversing this? Yeah. I'm going to reverse this equation so that O3 comes on the product side and can be cancelled and divide by 2. That is the reason I just focused on O3, not on O2. Yes, Avni, I answered your question.
Yeah.
Aditi, yours? Okay.
Yeah.
Yes, Kyra.
I have the answer.
Oh, what's the answer?
Negative 233.
Negative 233 units.
Kilojoules.
I can say per mole also because these are 1 mole each, right?
Yeah.
Is it exothermic, endothermic? Kyra, can you make the energy profile here?
Um,
Kyra, pick up the pen from here.
oh, okay.
Would it be
Mm-hmm.
exothermic?
Yeah, it is. So Kyra, can you make the energy profile? She said it's exothermic. Okay, let's say reactant is here. You remember energy profiles? Kyra, any difficulty?
I was wondering if it was like the one where there's like an exothermic in it, or is it like, yeah, that one, yeah.
Now draw. You have to make exothermic.
Wait, that was a mistake.
Yeah, no problem. Just ignore it. Start from here. Reactant. Then you have to decide the product will be less in energy or more in energy. You said exothermic. Okay.
like that.
Yeah, very good. Like that. And what is delta H? This is product. And what is delta H?
Um,
This one. Right? Now, Kyra, can you tell me what is more stable here, the reactant or product?
the product,
Why?
because it has less energy than the reactant and
Yeah,
utilize
this,
less energy.
yeah, and this reason is called as thermodynamic. The products are thermodynamically more stable because they have less energy. Very good, Kyra. Excellent. So please understand these energy profiles. So every time when we'll do some reaction, we'll calculate delta H of the reaction. You will be making the energy profile. What is this called as? Anyone? This energy, what is it called as? Avni? Yeah?
Is it the activation energy?
Yes, activation energy. Aditi, what was your answer?
It was also active.
Okay. Okay, that's good. Activation energy. EA, remember? EA, activation. If activation energy is high, then the reaction is slow or fast? Yes, Aditi.
Would it be fast?
Okay, check here. This is a reaction, and this is the activation energy of this reaction. And this is another reaction, and this is the activation energy of the other reaction. Which reaction is faster?
The one with less
Oh, the
activation.
one with less activation.
So write down, this is activation energy. Whenever we talk about activation energy, it means E activation is related to kinetic factor, kinetics. What are kinetics? How slow and fast is the reaction? Slow or fast? That is kinetics. And energy of the product is thermodynamics. Thermodynamics is energy of the product, stable or unstable. Okay, now we are for the next question. Read this question and give me 1 second. Okay. So you can see the desired equation here. Use the trick which I was telling you. Focus on unique reactants, unique products. Is this N2H? Yes, Avni.
Wait, do you have to use all of the equations?
Yeah, definitely. Otherwise, you won't be able to get the right answer. Don't worry about water because water is a part of every equation. So don't try to balance it. Just see this N2H4. I think it's the part of only one reaction, right? No, it is also of two. Okay, just ignore it. N2, is N2 the part of multiple reaction? No, it's the part of only one reaction, right? So let's decide for N2. How you're going to take a first equation? I'm focusing on N2 because rest all are the part of multiple reaction. Yes, Kyra.
You're gonna divide the entire equation by 4.
Yeah, let's do that. NH3 1/4 plus 3/4 N2O. And rest all reactant products are the part of multiple equations. So it means I'll start focusing on this now. 3/4 H2O. Now check ammonia. Is ammonia present in any more reaction? Just focus on ammonia from here.
Yeah.
Here, from here.
Yes.
It is.
So what
is.
are you going to do with this equation 3? Yes, Avni?
Wait, I think it's wrong. Isn't it supposed to be 2/4 for ammonia?
Oh, which
Yeah,
is 1/2.
1/2.
Okay.
Mm-hmm.
Yeah, 1/2.
3/4,
Yeah.
4. Yeah, thank you very much, Avni. Okay, now I have to cancel this ammonia. So which equations should I use and in which manner so that this ammonia cancelled out? Yes, Aditi.
You use equation 3.
And I cannot use it as such. What should I do? Do I want ammonia on the reactant side or product side? Because this ammonia is on the reactant side.
Then you are on the product side.
And divide by
2.
4.
Oh, wait, 4, yeah.
Yeah,
So
okay,
yeah.
good. Mhm.
Yeah.
So let's divide it by 4 and reverse it. N2H4 1/4 plus 1/4 H2O
H4.
giving you 1/2 NH3. I think I have taken care of NH3 now, right?
Yeah.
And 1/8 O2 and delta H3 minus divided by 2, 4. And delta H1
Divided by 2.
divided by 4. 4. You remember delta H1 also we
4.
divided
Oh,
by
4,
4.
sorry.
Yeah, the first one.
Yeah. Yeah.
Okay, now you see here I'm using very different technique because other reactants products are not helping me. Now let's focus on this N2O. So should I take N2O from, I have to cancel it. Yes, Kyra.
I have a question. It's kind of like a clarifying question. So for delta H3, that is a negative sign. So does that mean that like you do negative on the negative, so
Of
it's like
negative, positive, yes.
okay.
Negative here means reversal of sign. If it is negative, it will become positive. If it is positive, it will become negative. Take care of this N2O. Which equation will help you? Because
2.
N2O is also in equation 2 only. There is no other equation with
2.
N2O. So don't focus on water. Don't worry about O2. Just focus on N2O. What should I do?
You want to move it to the product side?
And
uh,
multiply by 3 over 4?
multiply 3/4. Yeah.
3/4. Let's do that. So 3 over 4 N2H4 plus 3 over 4 H2O, giving you 3 over 4 N2O, 9 over 4 H2. H2 is not the part of the final equation, right? So focus on H2 now. We are left with only one equation, this equation. Rest all are used. And this equation will help you in taking care of the H2. Yes, Aditi.
What about O2?
Oh, it will taken care. Don't worry. O2 is in this reaction. So don't worry about it. O2, water. You see, I said don't worry about water. They will be taken care. I'm focusing on unique, the one which is present only in one. So just take care of this H2. Kyra, can you help me how to take care of this H2? Yes, Kyra.
You would use the fourth equation and you would have 9 over 4 to different
H2.
times 9 over 4.
Okay.
I also have 2 questions.
Yes, please.
So the first question is for the equation above. Isn't it H2? No, like the third equation, like that you wrote.
This third equation, delta
No,
H3.
the third equation that you were writing.
Okay,
This
here.
Isn't it 2, like -3 delta H2?
Divided by 2. That's what you are saying?
No, like isn't it delta H2? Because delta H3 is the one above.
Okay. Yeah.
And my other question was, why is there a 3 in front of delta H2?
We multiply the whole equation by 3 over 4. You see, we were trying to get rid of this N2O, which is there over here. In the first equation, you have 3 over 4 N2O, and we were trying to get rid of this. So that's the reason we reverse the equation, because N2O is in equation 2 only. So we reverse the equation, we multiply it by 3 over 4. That's why. Avni? Okay, now add all these equations. We'll come to know whether we are right or wrong. If we get our desired equation, then fine. Otherwise, we did some error. Okay. Is this 3 over 4 N2O, 3 over 4 N2O cancelled?
Yeah.
9 by 4 H2, 9 by 4 H2. Yes, yes. Aditi, what else is cancelled? Ammonia should also cancel. Is it cancelling
half
out?
ammonia.
Yeah.
Yeah. Also, wait, I think that.
Now add this 3 by
Yeah, I think
4
that's it,
and 2. Yeah, can you add this?
One. Just.
Yeah, just one. And I need one.
Yeah, just enter each one. Oh, yeah.
Can you check how much water on this side?
Also one.
And how much on this side? 3. So 3 minus 1.
2. So 11.
Yeah, I have 2. I need 2 water. See, 2 water.
Yeah.
Now N2 as such. Now check your oxygens. How many oxygens on this side?
9/8.
And this side?
1/8. So it'll just be
1/8.
like 2, like the
Just do
desired
9/8
equation.
minus 1/8, and you get 1.
the
So just
desired
O2?
equation.
Yeah. Are you getting your desired equation? Yes.
Yeah.
So whoever is going to tell me delta H of the reaction, that person is going to make the energy profile also. Calculate delta H of the reaction and give me the accurate answer. Here is the energy. Here is the progress of the reaction. I'm starting reactant from here. Reactant. Calculate and make the energy profile. Okay, Aditi, your turn.
Got 3/2.
What's the answer?
Oh, I got 1.5.
Kyra, what is your answer?
I got negative 622.5.
Oh wait,
Yeah, that's the
okay, wait, I
answer.
saw my mistake, yeah.
Okay, you have seen your mistake?
Yeah,
Okay.
I
So Aditi, Kyra, let's give chance to Aditi. So Aditi, is it exothermic, endothermic?
exothermic?
Can you draw the energy profile?
Yeah.
Avni, can you draw the energy profile if I say this reaction is endothermic?
Okay.
Aditi, you are here, over here. Yeah, show me everything. Yeah. And Avni, you are making it here. Progress of the reaction here. So, yeah, activation energy. EA.
Wait,
EA. E with small a.
E is.
Yeah.
am I doing endothermic or exothermic?
You are doing endothermic if the same value is this. So, Aditi, your product is stable or unstable?
My product's more stable because it has less energy.
Yes, yes, yes. Good. Less energy means more stable. And Avni, your product is stable or unstable?
Unstable.
Because it has?
More energy.
Yes, right. Okay, so this is the story about the Hess's law. We are left with 6 minutes. So one last question on Hess's law, but it's not ending. In the next class, I will introduce you with enthalpies of formation and we'll do more questions. Few of them will be Hess's law. 76. This is the most important topic for organic chemistry, for AP chemistry, for any chemistry, the thermochemistry, thermodynamics. Teachers are taking so much interest and examination papers are dominated by the concepts. Concepts are simple. You have to just practice them. Okay, let's do this. Keep telling me how to proceed. This is the desired equation, children. Focus is on the desired equation. Yes, Aditi?
So if you're going to use this, focus on the unique reactants and the unique products.
Mm-hmm.
So if you look at the desired equation, or look at all the equations,
So is P4O10 in one equation or multiple equation?
It's in one.
So what should
So
you do?
that is, you should use that equation.
In which manner? Should I take it as such?
I think you should just take it as such.
Flip the side. That's what you are saying? Yes, Avni.
Yeah, because it's on the
Okay.
product side, so you
Okay.
go to the reactant.
So flip it. That's what Aditi is saying. P4 plus 5O2. So what is delta H2? Minus delta H2.
Yeah.
And I have not done any other changes. Okay. Now, next, just pay attention to unique. Don't worry about O2. It will get adjusted. Don't worry about Cl2. It will get adjusted. What is the other unique?
CL5.
This one. Right? Also, oh, PCl5. Is it unique? PCl5. Where is, yeah, it is.
Yeah.
It is unique. So,
You can multiply it by 6 and move it to the other side. So
flip it.
yeah,
Either you say the word flip the equation or you say reverse the equation, right?
Mhm.
So minus 6 times
Yes.
delta H 3.
3.
Now this is also unique, right? Here in the last.
Oh.
Do not worry about chlorines and we'll see them in the last.
So you just multiply the equation by 10.
And take it as such.
You'd
Very,
multiply it by 10.
yeah.
And
Multiply by 10 and take it as such. No reversal, right?
yeah, and you don't get flip or reverse it.
And delta H4 multiplied by 10.
10. Or
Now, what else? Now you have used 3. You are with all the reactants and products. Now you have to see what you want to eliminate. What is there? Not the part of the final equation. Yes. Anyone else? Only Aditi? Yes, Kyra.
You don't want P4, you don't want O2.
Yeah. Don't worry about O2. I said in the starting.
Oh, and Cl2.
Don't worry about them, right? Just think about P4 because P4 is only in one of the equation. This equation you have already used, right? So only left equation is 1 and that will help you in eliminating P4. So how should I use equation 1? Because we have already used these 3. See here. How should I use equation 1 so that P4 can be eliminated? P4 is on the product side. So, yes, happening.
You just put it into the equation like as it is because then it'll cancel.
Now just add all of them. Just add all of them. P4 cancelled. What else is cancelled?
Six. Oh. 6 Cl2.
Am I missing something? 6Cl2. Where is 6Cl2? Here? And here. Yeah. Okay.
And the
I think,
502.
okay, cancelled. Good. See?
yeah.
And I think this is also cancelled. This 6 plus 4 is 10 and is 10.
Yeah.
And
Yeah.
you are left with your desired equation. P4O10, 6PCl5. 6PCl5, yeah, here. This one. And 10 of this. So P4O10 plus 6PCl5 giving you 10 Cl3PO. I have to end the class now because I have another student. So I take it that Hess's law is done. Okay, good,
Yeah.
great. See you in the
Yeah.
next class.
Thank you. Bye.
Welcome.
Thank you.
Bye. Bye. Bye.
Bye.
Bye.